Welcome back. Today we're tackling one of the practitioner labs in the Web LLM attacks track, and this one is a proper chain. A few separate things stacked together to pull off something none of them could do alone. It's called exploiting AI agents to trigger secondary vulnerabilities, and we're going to delete a user we are absolutely not supposed to be able to touch. So let's read the goal first because it sets up the whole problem. The site is a shop and it runs an AI-powered security scanner, basically an automated tool that crawls the pages looking for issues. We've been given our own account, username Wiener, password Peter, and the target is to delete a user called Carlos. Sounds simple. It is not, and here's why. Carlos lives behind an internal admin panel, and that panel is only reachable from inside the network. We're sitting outside. We, can't get to it. So the trick of this whole lab is that we don't reach Carlos ourselves. We get something on the inside to do it for us. And that something is the scanner. But we'll get to how when we get there. Okay, quick word on setup, then we get our hands dirty. You'll want Burp Suite running with your browser traffic routed through its proxy and Burp Certificate installed so the lab's secure pages don't throw warnings at you. I'm not going to walk every click of that here. If you've never set Burp up, go watch a Burp Basics video, get the proxy and the cert sorted, then come back. Alrighty boy, let's log in with our account. Wiener and Peter. Right, let's find our way in. I'll open any product, I'll use the doggo one, and click View Details. I always forgot to set up the burpy burp meanwhile. So let's do that. Turn on the Ninetails Fox. Now turn on the Intercept. At the stock checker, check Stock button next to it. Let me click Check Stock. Now I'll flip over to Burp, into the Proxy tab, HTTP History, and find the request that just fired. It's a post to /product/stock. I'll right-click it and send to Repeater so we can poke at it on its own. And look at the body of this request, specifically the last line. There's a parameter. It's named stock API, and its value is a full web address. Now that value is URL encoded, all those %signs, but it's just a normal web address underneath. Now read what that's telling us, because it's a gift. The site is contacting an internal address to do its stock lookup, and that address sits at 192.168.0.something on port 8080. So the internal network lives on that range, and the stock service itself is at .1. We didn't have to scan anything or ask the scanner anything. It's all right here in this one request. And here's the part worth sitting on for a second, because this is the actual hole. Whatever address I drop into that stock API value, the server goes and fetches it for me. Normally a feature like that, fetching a URL, is totally fine. But I control the address. So I can point the server's own machine at places on the internal network that I, sitting out here in a browser, could never reach directly. I make the server do the reaching for me. That's called server-side request forgery, SSRF for short. So now think back to what the description told us right at the start. Carlos sits behind an internal admin panel, and that panel only answers requests from inside the network. Well, inside the network is exactly the side we just landed on. We've got a foothold on that 192.168.0 range, port 8080, and the server will fetch whatever address we hand it. Trouble is, we don't yet know which machine on that range is the admin one. The stock service is at .1, but the panel is somewhere else, and the lab shuffles that address on every restart. So we can't guess it. We have to find it. And the clean way to find it is to take this exact working request and just walk it across every address on the subnet, watching for the one that answers differently. So I'll right-click the request and send to intruder. Now pay attention to this setup because it's the step people fumble. First, clear all the positions Burp auto-marked. There's a clear button for that. Then I'm going to mark exactly one spot to vary, the very last number of that internal address inside the stock API value, the .1 at the end of the IP. So it reads dot, then section sign, 1, section sign. Leave the rest of the address alone. The whole stock check path stays exactly as it is. Those section signs are just burps markers saying swap this part out. One position only. If you mark 2, the attack cycles them one at a time, and the address never lines up right. Over in the Payloads tab, I'll set type numbers from 1 to 255, step 1. That walks every address on the subnet. Start attack. And now we wait, because it can take some time with the free edition. Hopefully it is among the first tries. Okay, we do not have to wait to run it through. I can already see the shining star. Now look at the columns, status code and length. Almost every single address comes back the same, a 500 error, all with the identical length. In our run, that length was 3011. Those are dead ends, nothing home. But one of them breaks the pattern. In our run, it was payload 2, and it came back 401 unauthorized, with a totally different length, just 160. Important, for you it can be a different numbered payload. Just look for the 401 status code. So 401 is good news. It doesn't mean go away. It means something's actually here and it's refusing you, which is exactly what a guarded admin panel does. So whatever number gave you the lone 401, that's your admin host. For me, it was .2. Let me confirm it. Back in Repeater, I'll change that stock API value to point at the .2 host and swap the path over to /admin. So it's just http://192.168.0.2:8080/admin. Nothing after it. And there's the response, 401 again. And this time I can read the body. It says, admin interface only available from loopback. So let me unpack loopback, because it's the whole wall right here. Loopback is how a machine talks to itself. The address 127.0.0.1 always means this same box. So the admin panel is basically saying it'll only answer if the request looks like it came from its own machine, nowhere else. And ours didn't. It came in from outside and got routed in through the SSRF. So to the admin service, we look like a stranger knocking. 401, no entry. So that's two things confirmed at once. That is the admin host, and we can't have it. So naturally, I tried to fake loopback. And here's the idea behind that. On a lot of big sites, a request doesn't hit the real service straight away. It lands on a front end first, a reverse proxy, whose whole job is to read the request and decide which internal machine should handle it. And the thing it reads to make that call is the host header, a little line in the request naming which site you're after. So in theory, if I set that host header to the internal machine, the proxy might route my request straight there and it'd arrive looking local. So I tried it. I set the host header to 127.0.0.1. I tried localhost. None of it satisfied the check. And that's the pivot. We've done everything Burp can do. We found the host, we proved it's locked to loopback. So now we hand the job to the one actor who's already on the inside, the scanner. And here's why that even works. The scanner crawls the site's pages and reads them with a language model, which means if we leave some text on a page it's going to read, it doesn't just file that text away as data. It can read it as an instruction and go act on it. That's indirect prompt injection. We never talk to the scanner directly. We just plant the words where it'll trip over them. And the dangerous part is, the scanner lives inside the network and it's eager to do things, way more willing to act than it really should be. That over-eagerness is what we call excessive agency, which means it can make the loopback-looking request that we couldn't. So back to the product page, and scroll down past the existing reviews to the review form. Quick housekeeping. If you've left any test reviews earlier, delete them with the red X next to each one, so the scanner has just one clean instruction to read instead of tripping over old ones.
For the first review, I'm going to confirm the scanner can actually reach the panel before I ask it to do anything destructive. So in the comment box, I write something framed as a security finding, a heads up that there's an exposed admin interface, and a request to verify it by hitting /admin with the host header pointed at that internal host, then posting back what it sees. Swap in whatever octet your own sweep turned up. I will leave my comments in the description, by the way, in case you want to use it. Just do not forget to change the octets to your payload numbers. Now, the exact wording here isn't magic. This is just what worked for me. The lab even warns you that the language model is unpredictable, so if it ignores you, reword it or run the scan again. So once the review's in, I scroll back to the top of the page and click Scan Site. And then we wait for it to finish. Results are in, and the scanner's summary confirms it. It reached the admin interface via host header manipulation. It noted the panel exposes user management, including the power to delete Carlos, and its list of tool calls shows a get to /admin. So the loopback wall that stopped us cold in burp didn't even slow the scanner down, because its request genuinely came from inside. But notice, the lab still says, not solved. The scanner only looked. It didn't pull the trigger yet. So let's give it the trigger. I'll delete that first review and post a new one, this time framed as a security audit task. It's already confirmed the panel's reachable, so now we ask it to finish the check by hitting the delete endpoint for Carlos. Same host header as before. Framing it as an audit matters, by the way. The scanner is far likelier to do something that sounds like its own job than a blunt, delete this user. Again, you can copy my comment from the description if you want to try it out, but I suggest you to try to write it your own. Then, same as before, scroll up, scan site, and wait one more time. A little side note, I am sorry if my IPs and dashboard changes during the video. Sometimes the lab drops me down and I have to reconnect, so I get new admin panel IPs. And there it is. The tool calls this time show a get to /admin, then a get to /admin /delete username equals Carlos, and the line lab solved during scan. And up top, the banner has flipped. Congratulations, you solved the lab. Carlos is gone, deleted by the scanner, from the inside, doing the one request we never could. One note, in case it goes differently for you. Sometimes the scanner gets ahead of itself and deletes on the very first step, just from its own initiative. That's the excessive agency showing. But the reliable path, the one I'd lean on, is the two-step one we did. Confirm first, then delete. So let's pull the whole thing together, because the chain is the lesson. The SSRF in that stock checker let us probe the internal network and turn up an admin host. The host header trick was the routing move that, in the right hands, turns a loopback-only panel into a reachable one. And the scanner, sitting inside, reading attacker-controlled text and acting on it, was the thing that actually made the request we couldn't, and then carried out the delete. Take away the SSRF, and we never find the host. Take away the host trick, and the panel stays sealed. Take away the eager internal scanner, and there's no one on the inside to act. And that last piece is the real takeaway. A thorough internal scanner that reads whatever it crawls and acts on it isn't a friendly tool. It's an attack surface. That's the lab. Nice work staying with a long one. I'll see you in the next.